Hello, grade 9 learners! In this video, you are going to learn about the 6 trigonometric ratios. I am Melanie and I will be your tutor for today. I know that everyone is already excited with our lesson. Let us now know the different learning objectives. First, illustrate the 6 trigonometric ratios. Second, apply the trigonometric ratios in solving for the unknown quantity of a right triangle. Okay, so before we proceed with our main discussion, let us have first a short activity. So I have here a right triangle, A, B, C. Right angle is at angle C, and the measure of angle A is 30 degrees. Let us answer the following question. Number 1. What is the opposite side of angle A? You're right. Side BC is the opposite side of angle A. How about what line segment is our hypotenuse? You're correct. Side AB is our hypotenuse. But how about the opposite side of angle B? Great! Side AC is the opposite side of angle B. What is the measure of angle C? Good job! Since angle C is our right angle, therefore the measure of angle C is 90 degrees. How about the measure of angle B? Right! Angle B measures 60 degrees. Pythagorean theorem is very useful in solving for the right triangles. However, its function is limited. Who do you think is in the picture? Correct. He is Hipparchus. Through Hipparchus, known as the father of trigonometry, he studied the relationship of the sides and their opposite angles in a triangle. He is the one who introduced the 6 trigonometric ratios and function. Alright, so these are the basic words that we need to consider in studying trigonometric ratios. First, theta. Theta is a symbol used to denote the unknown measure of an angle. Take note of the word unknown. Next is opposite side. When we say opposite side, that is the side opposite the angle of interest or the angle theta in a triangle. Next, hypotenuse. So when we say hypotenuse, that is the longest side in a right triangle. And lastly, when we talk about the adjacent side, that is the side next to a given angle. For you to better understand about the basic of trigonometric ratios, let us illustrate that in our example. So I have here a right triangle ABC. In triangle ABC, let angle A represent as theta. Then, the leg denoted by B is the side adjacent to theta. And the leg denoted by A is the side opposite to theta. That means, if our angle A is our unknown angle, meaning to say, the side opposite to angle A is what we called as opposite side. And the side adjacent to angle A is what we called as the adjacent side. And the longest side of our right triangle is our hypotenuse. Alright, so let me discuss with you the basic 3 trigonometric ratios. And the first one is the sine, or that is written as sin. Sine is the ratio between the opposite of the given angle and the hypotenuse. That is written in the mnemonics SOH, or SOH, meaning to say
sine theta is equal to opposite over hypotenuse. So, since side A is the opposite side and side C is the hypotenuse, so therefore, our formula for sine theta is equal to A over C. To better understand with our illustration, if this is angle A or the unknown angle, or this will be called as the angle theta, the side opposite to angle A is side BC or side A. And the hypotenuse will be side AB or side C. The second trigonometric ratios is what we call as cosine, or that is written as cos. Cosine is the ratio between the adjacent side of the given angle and the hypotenuse, and that is written in the mnemonics ka, or that means cosine theta is equal to adjacent over hypotenuse. So since side B is the adjacent side and C is the hypotenuse, therefore, cosine theta is equal to B over C. That will be the formula that we're going to use if we are about to find for the angle theta using ka. So for you to better understand in our illustration, so we have triangle ABC. Angle A is the unknown angle, and angle C is the right triangle. If angle A is the angle theta, and the side opposite or the side adjacent to angle A is side B, and the hypotenuse will be AB or side C. Okay, so the third to the three basic trigonometric ratio is what we call as tangent. So that is written as tan. Tangent is the ratio between the opposite and the adjacent sides of the given angle. That is written in the mnemonics TOA. TOA is also the same as tangent theta is equal to opposite over adjacent. So since side A is the opposite side and B is the adjacent side, therefore, the formula that we're going to use for tangent theta is equal to A over B. In our illustration, we're going to consider opposite and adjacent side. If this is the angle theta, the side opposite to angle A is side BC or side A. And the adjacent side or the side next to the given angle is side AC or side B. Alright, so now that you know already the three basic ratios, the next three trigonometric ratios are the reciprocals of the three basic ratios. Cosecant is the reciprocal of sine. Cosecant is written as CSC. It is the ratio between the hypotenuse and the opposite side of the given angle. Or, we're going to use the formula cosecant theta is equal to hypotenuse over opposite. So, in cosecant, we're going to focus on the hypotenuse and the opposite side. So, from our given right triangle ABC, our angle theta is angle A. The hypotenuse is side AB or side C. And the opposite side of angle A is side BC or side A. The reciprocal of cosine is the secant, or that is written as sec. It is the ratio between the hypotenuse and the adjacent side of the given angle. So we're going to use the formula secant theta is equal to hypotenuse over adjacent. Since side C is the hypotenuse and B is the adjacent side, therefore, secant theta is equal to C over B. Secant is the reciprocal of cosine. So, for you to better understand about secant, in this example, our triangle is triangle ABC. Angle A is the angle theta. So, in secant, we're going to focus on the hypotenuse and the adjacent side. So, if angle theta is angle A and the hypotenuse is side AB or side C, and our adjacent side is side AC or side B. So we're going to focus on these two sides. And we're going to use the equation secant theta is equal to C over B. And lastly, the reciprocal of tangent is the cotangent, or that is written as cot. It is the ratio between the adjacent and the opposite sides of the given angle. Cotangent is written as cot. Or we're going to use the formula cotangent theta is equal to the adjacent over opposite. Since side B is the adjacent side and A is the opposite side, we're going to use the formula cotangent theta is equal to B over A. Again, cotangent is the reciprocal of tangent. So to understand about cotangent, so in our example, we have triangle ABC. Angle A is our angle theta. So we're going to focus on the adjacent and the opposite sides of the given triangle. If the angle theta is angle A, the adjacent side of angle A is side AC or side B, while the opposite side of angle A is side BC or side A. So we're going to focus on these two sides. Let us use your knowledge about the six trigonometric ratios in our example. Given right triangle XYZ, angle X is the right angle. Define the six trigonometric ratios for angle Z. Alright, so let's have our solution. It is important for us to understand the given triangle. So our given triangle is triangle XYZ. Angle X is our right angle and angle Y is our angle theta or the unknown theta. It is also important for us to identify the given. Remember that our theta or the angle theta is angle Y. Looking at adjacent, opposite, and hypotenuse, we're going to consider angle Y as our theta. This is the unknown theta. So what is the adjacent side? The adjacent side is the side next to angle Y. So that is 6. That's why adjacent is equal to 6. And remember that the opposite side is 4. So that's why we have 4 here. And the hypotenuse, which is considered as the longest side, measures 8. By looking at the six trigonometric ratios, we're going to apply the mnemonics so, ka, towa, and the cho, shakao, which is the reciprocal of the soka, towa. So stands for sine is equal to opposite over hypotenuse. So based from our given that the opposite side measures 4, that's why we have 4 here, and the hypotenuse measures 8. That's why sine theta is equal to 4 over 8. Okay? Let's continue. Ka. Ka stands for cosine theta is equal to the adjacent over hypotenuse. So from the given, the adjacent side measures 6 over our hypotenuse, which is 8. That's why we have cosine theta is equal to 6 over 8. I hope you can still follow. We still have more. Let's now proceed to TOA. TOA stands for tangent theta is equal to the opposite over adjacent. So based from our given, our opposite side measures 4 and the adjacent side measures 6. That's why we have tangent theta is equal to 4 over 6. Okay, considering these three basic ratios, let's now proceed to the reciprocal ratio. So we have cho, shaka. We're going to apply this. So what do you mean by cho? Cho means cosecant theta is equal to the hypotenuse over opposite. Remember, that is the reciprocal of sine, which is the opposite over hypotenuse. So we have here hypotenuse over opposite. So our hypotenuse measures 8, while the opposite side measures 4. That's why we have here 8 over 4. Okay, next. Sha, or the reciprocal of ka. Sha, that means secant theta is equal to the hypotenuse over adjacent. Remember, from the given, the hypotenuse measures 8. So we have 8 here. And the adjacent side measures 6. That's why, for the secant theta, we have 8 over 6. And lastly, for our reciprocal of the tangent, we have the cow. Cow stands for cotangent theta is equal to the adjacent over opposite. So remember, from the given, we have the adjacent, which measures 6, while the opposite, which measures 4. So where did I get the so katowa and the cho shakaw? So katowa, meaning to say S stands for sine, O stands for opposite, H stands for hypotenuse, Ka stands for cos, A stands for adjacent, H stands for hypotenuse. And towa, so that is the tangent. O stands for opposite, A stands for adjacent. Same thing with the reciprocal ratio, which is the cho, sha, cow. Cho stands for cosecant, C stands for cosecant, H stands for the hypotenuse, and O stands for the opposite. While sha, S stands for secant, H stands for hypotenuse, A stands for adjacent. And the cow, C stands for the cotangent, A stands for the adjacent, O stands for the opposite. I hope you get our first example. Let us have another example. Given the right triangle JAR, angle J is the right angle. Define the 6 trigonometric ratios for angle A. Alright, so let's have our solution for the second example. So just like what I have said earlier, it is important for us to understand the given triangle. So our triangle here is triangle JAR. Triangle JAR. So we have angle J as our right angle and angle A, which is our angle theta or the unknown angle. Let's now have our given. So remember that our angle theta is the unknown angle, and in our given, that is angle A. So what is the adjacent side? So when we say adjacent side, that is the next side after the given angle or the unknown angle. So if this is the unknown angle, so the side next to it is side R. That's why we have R here. And the opposite side of our angle theta is side A. And the hypotenuse, which is the longest side, is considered as J. Let us use our SOHCAHTOA and the CHO-SHAKAW to determine the 6 trigonometric ratios of the given triangle. So here, So again, stands for sine theta is equal to opposite over hypotenuse. So based from our given, our opposite side is A and the hypotenuse is J. That's why for sine, we have A is equal to A over J. Next, ka. Cosine theta is equal to the opposite or adjacent over hypotenuse. So based from our given, the adjacent side is R and the hypotenuse is J. So this is just very easy, you know. We have the TOA, tangent theta is equal to the opposite over adjacent. So our opposite is A and the adjacent side is R. So these are the three basic ratios. Let us now have our reciprocal ratios by using the cho, sha, cow. Cho, cosecant theta, is equal to the hypotenuse over opposite. Cosecant A is equal to J over A because the hypotenuse is J and the opposite is A. Next is sha. Sha stands for secant theta is equal to the hypotenuse over adjacent. So secant A is equal to, our hypotenuse here is J and our adjacent here is R. Next is the cow. Cotangent theta is equal to the adjacent over opposite. In our given, the adjacent is R and the opposite is A. I hope everyone understood the two examples given. Okay, so I know everyone already knows the six trigonometric ratios. So you're just going to apply the mnemonics SOHCAHTOA. So for your application, kindly get a sheet of paper and answer this. Given right triangle JAP, angle J is the right angle. Define the six trigonometric ratios for angle E. You can use the examples earlier for you to answer this application. I'm going to give you 5 minutes to answer this. Okay, so a very good job to everyone. You really understood the lesson because you have already your past score. Okay, so for your assignment, you're going to define the six trigonometric functions of angle R. So our given is a right triangle RST. Thank you for listening. Until our next lesson, goodbye!